Hi, and welcome to today's lesson on solving four-step equations. Okay, in our last lesson, we learned how to do a three-step equation, and we saw that there were a bunch of different varieties of three-step equations. Today, we're going to take some of those different varieties and mix and match them so you can see that really, if you can solve a three-step equation, especially if you can solve all the various types of three-step equations, going to a four-step equation, not that big a difference. You just got to go, hey, I can do it with this step, or I can do it with this step, I can do it with both. So let's look at a fairly complicated little thing here. And I always want to talk a little sometimes about how you'll see it presented to you in a test or on a worksheet or whatever. There's all these different ways to say the exact same thing. Sometimes they say solve. Sometimes they say find the solution. They say sometimes solve for x. What's the variable? All these different ways of just saying solve it. Okay, so we go 6x minus 2 parentheses 2x minus 3 end the parentheses equals -7. I think that's a pretty substantial problem. That's one thing that I really feel good about. When we get to this moment, if you've been showing your steps, showing your work on every problem, if you've been walking through it carefully, methodically, 1, 2, 3, you're up to 3, 4 is no big deal. It looks like a lot, and I guarantee you go home and take this problem to your, I don't know, your 4th grade little brother or sister and show it to them and say, okay, this is what you're going to be doing in the 8th grade. They're going to look at you like, oh my, this is crazy. What is going on? Well, there's things I don't even understand. What's the this is like sick. Is this they don't understand this at all. Okay, you do. Okay, so again, we're poor sad meat, but we're adding, if you remember from the last lesson, right in here between P and S is the combining of like terms. Parentheses is the distributive property. That's that rainbow. That's multiplying a number that is outside of a parentheses times all the numbers that are inside the parentheses. And this is going to be a really important one. So that's what I really want to, one of the big deals of this particular problem that makes this one even a little more challenging than maybe just your typical 4-step equation would be. Subtraction and addition, we know those things go together. Division and multiplication, we know go together. And exponent is, we're only going to use it for square roots, but when you get into high school and beyond, you might see cube roots, fourth roots, and beyond. We're not going to get there. We're not going to bother with those things. Those are more complicated than we need to deal with right at this moment. So let's start with the beginning, because as soon as I saw that parentheses, I knew what I needed to do, because it says it right here, it's first. Okay, that's the parentheses. Purpose in life is to tell us, the person solving the math problem, deal with this first. Okay, and it's stuff you would even like, imagine for a moment that we were all in a business proposition together. We were all working together, and we all went out and sold whatever it is that we sold door to door, and when we all got back together, we would take, and we were going to split the profit, right? What would we have to do? We'd have to add it all up first. That'd be the parentheses. We'd have to take all the money and add before we could divide. Normally you divide before you add in the order of operations, but in our case we'd have to add first, so we would put a parentheses around it. That's, again, we just start doing those things inherently. We don't even think about what does that mean to have a parentheses. Why is it there? It's telling us to deal with it first. That's what it's telling us. Now here's the other part that's really the big deal. And that is this minus sign right here. Okay, that is really critical to this problem. Okay, because the number that is being multiplied to all the numbers in the parentheses is a -2. Now, I'm going to write this problem again right here. So that I have some room, because I want to do two things. Number one, I want to make it really clear why this is a -2, and I'm going to put some cheese on a whole bunch of things. We're going to keep that 6x. I'm going to switch this to addition, and I'm going to change the 2 to its opposite and make it a -2, and that's the number that's going to be distributed. But you know what I'm going to do before I get there? I'm going to do the same thing here. I'm going to keep this 2x, I'm going to switch this subtraction to addition, and I'm going to change this 3 to a -3 to really make sure I know what the signs of all the numbers involved in this process are. Because now I'm ready to distribute. So I'm going to draw my little arrows. So the 6x is not going to do anything, it's just going to come down. I have -2 times +2. A negative times a positive. Remember, if the signs are the same, it's positive. These signs are different, so it's going to be negative 4x. I have a -2 times a -3. Well, a negative times a negative, that's positive. You see how the signs are becoming not just the operation, but also the signs of the number. Those things go hand in hand. They're interchangeable. Okay? And then still have that equals -7. So now I've done my distributive property. And there may come a time, and I don't mean like distant future, I mean like this week, where you have multiple parentheses to deal with. Okay? And you really have to pay attention to each one, and each one has to be done separately. And you would work on them from left to right. So if you had 2 parentheses, one here and one here, you would just do this one first and that one second. There even comes a time when you'll have parentheses inside of parentheses, and they have a totally different symbol for that we haven't gotten into. We're not going to talk about that right now, but we might eventually get a chance to talk about parentheses inside parentheses. Maybe even go parentheses inside parentheses inside parentheses. Crazy, but I know, we'll do it. So we've done our distributive property. Next up is to combine like terms, and I see that I have some variables that have like terms, and I got to deal with that because I can't solve for them there's not like solving for them one at a time. They're all the same x. I have to solve for them together. So 6x minus 4x, that's some pretty basic arithmetic. I don't really have to worry too much about it. And there it is. Okay? And excuse me. If you wanted to change the -4 to a +4 or plus -4, you could do it. You could do a little more queso. But I figured 6x minus 4x was pretty straightforward. Okay? And then, now we're right down here. Our last 2 steps, we've done this many times already. We're going to subtract 6. And we're going to divide by 2. And I'm not getting a whole number, so I'm perfectly happy leaving it as -13/2. If I have to, or if you really want to, you can turn that into -6.5. Again, no mixed numbers. Okay? Improper fractions are fine. Okay? Decimals are okay, but they usually just involves more work than you want to do. When I can stop here, why bother doing the long division to get this? Yeah, it's not really hard because dividing by 2 is not that challenging. But if it were -13/7, I certainly wouldn't want to do it. I'd get a long repeating decimal, and that would be a pain. Okay? So when you're presented with a fraction, I suggest strongly you leave it as a fraction. The only time I would ever change it is if I was doing something where I had answers of a variety, like I was doing a multiple choice test, like maybe the SATs, and I said, okay, well, their answers are all decimals, then I'm going to have to turn it into a decimal. But I would look at the answers before I made that decision. I would not make that decision just because I felt like it. I would go, hey, all their answers are decimals, I better turn it into a decimal. But if they have fractional answers, then I certainly don't want to waste my time doing that and then find out that that was the way they wanted it written anyway. Okay? So you're definitely, so now we have 4 steps, right? Parentheses almost always follows combining like terms, almost. Okay? And then subtraction or addition, and then division or multiplication. It's possible to have both. Again, these would turn these into 4-step equations into 5 or even 6. And they don't consider it an extra step, and by they I mean whoever calls it a 4-step equation, myself maybe included, if you do the same step multiple times. So if I told you there were 2 parentheses, even though you had to do parentheses twice, it would still count as 1 step. This is the step where we do all the parentheses. So let's look at one more really crazy involved problem, and then we will be done. So we'll go 2 times 3x plus 4 minus I'm not even going to put a number. I'm just going to say minus, and then a parentheses, x minus 3, and that equals negative 18. I got to tell you, that looks complicated to me. This is where I have those students that have been all along telling me, oh, I just know the answer. I did mental math. I did it in my head. I got it. I don't need to show my work. I totally get it. I know what I'm doing. And then they get to this problem and they go, I don't know. And they just stare at it and they go, I don't know what the answer is. And they go from it's easy to I can't do it. And there's no middle ground thing. And that's why I'm so determined to make you show your work. That's why I won't give you credit for work if you don't. Okay, turning in homework with no work shown is not worth anything, because what'll happen is you'll get to here and then you're stuck and you're not able to make that transition to that next level of difficulty because you've never bothered with the easier levels of difficulty. Okay, so please don't shy away from showing your work just because most of the time it's because you think it's too easy, or B, you're just lazy and you don't want to do all the writing that would involve showing your work on a 4-step equation, especially if you have to do 10 or 12 or 15 or maybe even 30 of these things, 40, I don't know. You don't want to show your work, and therefore you think, oh, well, I don't want to show my work, so I just won't. Okay, don't be that. Don't be like that. Show your work. Make sure you know how to do this. Be confident when you get to the more complicated stuff. Long after you've left me, you're still going to be using this, I promise you, and you're going to be so glad you know how to do it. So let's walk through this slowly and methodically, okay? Especially when we talk about what's going on right there. That's some confusing stuff, I know. So we're going to start with parentheses. That's always going to be step 1. We're going to deal with that. We're going to do the distributive property. So I start with that very first parentheses I see. So 2 times 3x is 6x. 2 times positive 4 is positive 8. Now, what is going on right here? This is confusing, I know. A lot of people struggle with this. The real question is, when you don't see a number, what number is there? If you see something but there's no number, what is it? Well, just like in English, if I ask you what I was holding in my hand, you wouldn't tell me I was holding one pen. You would just say a pen. So when I say a pen, or I see a negative sign, what's the number? Well, that number is 1. In this case, it's actually negative 1. So I'm going to be distributing this negative 1 to the x, so that's going to get me negative 1x. I'm going to take this negative 1 and distribute it over here to this negative 3. And I think it's always helpful to circle the number with its sign. I think that will add to understanding, make it a little easier. But a negative 1 plus times a negative 3, negative times a negative is a positive. 1 times 3 is 3, equals negative 18. So I had to do the distributive property twice. Now I got to combine like terms. And again, I'm going to have to do this twice because I have a 6x and a minus 1x. 6 minus 1, that's 5x. I have a positive 8 and I have a positive 3. That's going to get me a positive 11. Then now I'm back down to these. Subtract. And again, make sure you're very careful. I hate when people do all this good work and they're very methodical, and then they get to the negative 18 minus 11 and they mess it up. Maybe you want to pull it aside. Maybe you want to put a little queso on it right there. But please make sure you're doing whatever it takes to get that as negative 29 instead of as negative 7 or positive 29. Don't apply a multiplication rule to subtraction. Just be careful when you're doing these problems. Okay, and then the last step, still going to be dividing. I told you you're going to do it 1,000 times. And I don't even want to deal with this long division, so I'm going to do it, just going to leave it like that. It's negative 29 fifths. Ugh. Okay, but it is what it is. That's the other thing. Notice I never worried about what the answer was. I didn't come up here and say, God, I hope this comes out to be positive, or make sure I know how to do it with a positive number or a negative number or a whole number. I didn't worry about it. I said, what do I need to do? What was my math requirement? 2 times 3, third grade, right? 2 times 4, third grade. -1 times x, -1 times -3. I don't know when you learned how to multiply with negative numbers. Maybe that was all the way up in the 7th grade or 6th grade. 6 minus 1, that's some good first grade, 2nd grade math. 8 plus 3, that's for sure first grade math. -18 minus 11, okay, we're back to that. Maybe that's 4th or 5th grade math. And -29 divided by 5, that might be, I didn't even do it. I didn't do the arithmetic. So, my math requirements were pretty minimal here. The key, what was our responsibility as 8th graders, as students who are in this section, was what order do I do things in, and making sure they get done correctly at every juncture, but in the right order. Because I assure you, if you try to add if you did 2 minus 1 before you did the distributive property, you're going to be way, way off the mark. So that's what we are working on. That is what we are learning how to do, and that is why 4-step equations aren't even that much more difficult than 3-step equations. They're just putting together 2 of those 3 possible steps we saw from the other day. Okay? All right. I hope to see you again soon. And as I step out, you'll see my cat. There she is. Isn't she adorable?